Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khurram, and in this channel I teach programming skills in Python, R and MATLAB. I also teach statistical theoretical concepts as well as practical programming skills in data analysis, statistical analysis, machine learning and data science. So if you're a person who wants to learn Python, MATLAB or even R from beginning, and if you want to actually excel the domain of data science, I suggest you to subscribe to my channel, hit the notification bell icon button. As I have stated earlier that I will be posting series of videos about statistical analysis in Python. So in today's lecture, I'm going to discuss about the variability of statistical dispersion. This is again one of the fundamental concepts in statistical analysis, and we are going to actually calculate that by the help of Python programming. So let us briefly discuss about what is variability is. So variability refers to the extent of separateness and dispersions in the data set. It quantifies how data point deviates from the central tendency. What is the central tendency? I have actually discussed that in my previous video, so you can go and check out that video. I will put the link in the description below. So it quantifies how the data deviate from the central tendency, which is actually quantifies what is actually the middle or mean or median. Okay, so central tendency actually quantify what is the middle of the data. So it quantifies how the data point deviates from the central tendency. What quantifies? Variability quantifies that how data point deviate from central tendency. Understanding variability is crucial because it impacts statistical conclusion and decision making. So variability is again one of the core very important aspect of data set, to such an extent like, for example, if you are formulating a hypothesis, the result of that hypothesis testing, whether to reject or accept null hypothesis, will be dependent on the variability of the data. Like they will actually play a major role in making that decision when we actually concluding the hypothesis by some statistical means, by some statistical test here. Okay, so just like t-test, ANOVA test and so on. So we have actually a number of measures or number of things that we can actually include in variability when we are actually talking about the variability of data sets in statistical dispersion or descriptive statistics. The first one is actually the range. The range is the difference between the highest and the lowest values in the data sets. It gives you an idea of how much the data sets varies. Then let's discuss about standard deviation. It represents the average distance of data point from the mean. So it represents what? An average distance from the data point from the mean. So any data set will have a mean value. It will actually represent the average distance for that specific data point from the mean. A smaller standard deviation indicates less variability, while a larger one suggests great separateness. Then we have variance. The variance is the average of the square distance from the mean. It quantifies how much data points deviate from the mean. And then finally we have interquartile range, IQR. This measures the middle 50% of the data, and it's the difference between the 75th percentile and the 25th percentile. I will discuss that concept later on when we are actually dealing with practical programming in this tutorial. So let's move on and actually jump on to the practical programming section here. So in order to actually calculate the variability of the data set, I'm going to import this module statics. Okay, so by using this Python statement, import statics. Once I have imported the module, let's move on to actually calculating first the range of our data sets, or in our case our data. So before we actually jump onto the function, so I have declared a list here, sample, by initializing variable name sample underscore data, and then I'm assigning a value list to its variable. Then within those lists we have some values and elements in it, like 72, 110, 134, 190, 238, 287, 305 and 324. So I have declared and initialized a list here. Now I have in order to calculate the range, I have actually formed a function, and the name of the function is calculate range, that takes a list as an input argument, and that calculates what? The range of that list. And how the range of list is calculated, we subtract the maximum value of the list within the list by the minimum value within the list. So this function, two functions here, max and min, actually takes the input argument our list, and they calculate the maximum value that is currently present in the list, and minimum actually calculates the minimum value that is present in the list. We take the difference, and that actually help us to calculate the range. So that's how the range is calculated. So for this, I am going to initialize another variable named range underscore value. Then I'm going to call the function and then pass input argument or declare list, and that will actually help us calculate the range of that specific list. And after that, I'm going to use the print function. Within the print function, I'm going to use fstring method. So those of you who don't have an idea about the fstring method actually is a way of embedding variables within a list, within a string. Okay, so how we can actually declare an fstring method? We first of all write f, then we put quotation mark, then we write whatever the text we want to write. Then for the variable embedding, we are going to declare it within curly braces. So, and the variable in our case is actually range value, which is the range of the list we have declared earlier. Simply, I'm going to run this block of code for you. Now we have a range of 252. Now you know how to actually calculate the range. Let's move on and actually discuss about how we can actually calculate deviation and variance of the data set, or the list we have currently used here. So we have actually already imported this module, so we are not going to import it again. So we have a list here. I have declared the same list here, like sample underscore data, and then I'm passed a list of element 72, then 324. And I have declared a function in order to calculate the standard deviation and variance. So I have named the function as calculate std and variance, that takes input argument or list we have declared earlier. Then it will call this module statics, and then use that method stdev and variance to actually calculate the standard deviation and variance. Once we have calculated that, I'm going to return those calculated values to the function whatever it was called. So that will be actually stored in these two variable names, st.dev underscore dev and variance. So as we have called the function here. So we are calling the function, we are passing the input argument. As a result of output, it will pass the two variables as an output, and they are stored in this variable names. So once you have done that, now you can actually print the values of standard deviation and variance. And for this purpose, I'm going to use the same print function and fstring method, but there is one additional thing that you actually see, that in declaring the variable within fstring method, we actually do see that we have like an additional term that is :2f. It actually helps us to define that whatever the value is we want to actually display its value up to 2 decimal points. So for 2f represent 2 decimal point, for f for float. Okay. So let me just run this block for code for you. So now you can see that we have standard deviation of 95.55 and variance of 9129.14. Now let's move on and actually discuss about interquartile range. That might sound a bit of overwhelming for someone who is not acquainted to this kind of concept here, but it's quite easy to understand, and let me help you digest that concept in an easy way. So IQR captures the middle 50% of the data. So whatever the data we have, the IQR actually help us capture what is actually the middle of the data. The 50%, what is the 50% middle of the data? So we are not talking about the one end or the beginning or the end. We are talking about something that is present in the middle. So IQR help us capture that essence of the data. It is the difference between the 75th percentile and the 25th percentile. So in order to understand this statement, you have to actually first understand the percentile. What do we actually mean by percentile? So percentile, in a sense, when you say we have 25th percentile, consider a list. We have like some values, some randomly distributed value like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We say that 25th percentile is actually value 4. So it represents that 25% of the data that is currently present in the list actually falls below 4. Okay, so that's what it means. So the 25% of the data, what are the quantity, what are the number of elements we have, out of those elements, or 25 elements. For example, we have 100 elements. Out of those 100 elements, 25 elements within that data will lie below 4. So that's what it actually means. So percentile, 25th percentile. So when we say 75th percentile, it means that 75% of the data, or let's say 75 elements has values that is less than, let's say, 7. So you get the idea. So that's what it actually means by percentile. So once you know how to define percentile, so basically IQR is just the difference between that value that is present at 75th percentile and the value that is present at 25th percentile. In our case, that will be 7 minus 3. So that's how you get the idea of percentile. So for this purpose, I have actually used the same analogy and concept in order to describe the example here. So if you have a data set with quartiles, Q1 is equal to 134 and Q3 is equal to 278, the IQR would be 278 minus 134 is equal to 153. So that's the same scenario we have described earlier with the example of 3 and 7. Good. Now, if you have any questions, you can comment down you can actually list down your question or queries in the comment section. I will be happy to help you out. So let's move on and actually help us calculate, and now let's calculate the IQR. For this purpose, I'm going to import a library NumPy, NP as NP, and I'm also going to import library Matplotlib and its module pyplot, and then we're using alias as plt. Okay, so because I will also show you how we can actually graphically visualize it, this concept we are actually discussing about. So first of all, I'm going to declare an NumPy array. So those of you who don't know about how to declare an NP array, I have actually a dedicated video on NP arrays, NumPy library, where I actually teach you how to calculate NumPy array through multiple ways. So it's a highly resourceful video. I will put the link in the description for you. So we will define here data is equal to np.array, then I'm pass the list of elements, and once I've done that, I have initialized my NumPy array and declare it to the variable name data. Now, in order to calculate the percentile, I'm going to use this method here of NP. This is percentile. So the first input argument it will take it's the data, and the second input argument is actually the percentile I actually want to calculate it. So in our case, we are interested in calculating the percentile of 75th percentile and 25th percentile. So that's why I have passed an additional input argument, which is the list that contains 75 and 25. So again, I repeat that this method here takes two input arguments. The first input argument is the data from which we actually want to calculate the percentile, and the second input argument is actually a list of elements which actually contains the percentile value 75 and 25. Once we have done that, it will give us two values, and that are stored separately in Q3, which represents 75th percentile, and Q1, which represents 25th percentile. Then we simply subtract Q3 minus Q1 to get an IQR. And finally, I'm going to print the value of an IQR. So let me just run this block of code for you. So now you can see that the percentile IQR is actually 12.25. That's good, we get the IQR, but I promised you that I will actually display this concept graphically so you can actually visualize it and understand it more effectively. So in order to do that, we are going to use the box plot here, which is quite famous in statistical analysis, and you have actually, some of you might have also plotted it earlier than before. In any case, so in order to plot the box plot, I'm going to call the library Matplotlib and its method fun module pyplot, and I'm calling it by plt as an alias. Then I'm calling its method box plot, and within those box plots I'm passing two input arguments. The first one is actually the data, and the second one is actually the axis where we want the values to be plotted, either in a horizontal axis or vertical axis. So in that case, I'm setting vertical axis is equal to 2. It means that I want those values to be plotted in y direction or vertical direction. Then simply we are going from additional input methods class here. We have like title, we have y label, title box plot of data, and then we have y label values. Then I'm going to use this class here, plot.show, and then finally this we are able to get this plot out of this block of code here. So as you recall, as you have told you that what is an IQR is the middle 50th percent of the data. So this box here actually represents the 50th percent of the data, and the very end you will get the 25th percentile, and the very top you will get 75th percentile, and within those percentile you will have the IQR. Now if you recall that, and you will say that IQR value is actually 12.25. now if you look at the top value, which is actually some approximately equal to 35, and you minus it by something around like 22.5, you will actually get 22.75, you will actually get 12.25. so that's the how you can actually graphically visualize the concept. So IQR is actually the middle 50th percent of the data that is falls in the middle. That's it for now. I thank you for joining me. I hope this video has been resourceful for you. If you have any questions, feel free to write down your questions in the comment section. I will be happy to help you out. And that being said, I would request you to subscribe to my channel, hit the notification bell icon, because soon I will be posting more videos related to statistical analysis, like regression analysis and all those concepts in statistical analysis, correlation plot. Then we have hypothesis testing and so on. Thank you for joining me.